Okay, good evening, everybody. This is a quick video on getting ready for the quiz. So modules quiz 2, we did this in class today, but here again, it tells you what to expect on the quiz. Now, if we look at our activities 4, 5, and 6, and then we're going to go look at my math labs 2, I believe that's, let's see, 2, 1, 2, 2, 3, 4, 5, and 6. Just to be clear about what's expected or what to expect on the exam. So for um, activity 4, if we scroll down, we had questions about average rate of change in velocity. You're not going to have to calculate any average rates of change with numbers like this. You could have to, or be asked to calculate average rate of change similar to what was asked on quiz 1, but with numbers that you can calculate with, not any decimals like this. Then what else did we do on activity 4? You had a graph, and on that graph, you had to be able to sketch a secant line, a line through 2 points. So given 2 points on a graph, could you sketch the secant line through those 2 points? Given, and that again, that secant line is representing, its slope is representing average velocity or average rate of change. The line whose slope is equal to instantaneous velocity is a tangent line at a specific point. So we want the instantaneous velocity at time 3. Well, here's the line, the tangent line at time 3, and it's the slope of the red line. That is equal to the instantaneous velocity at time 3. What else did we do? More instantaneous velocity and secant lines. Then here you had to calculate an average rate of change. Again, that's change in outs over change in ins with units dependent out units over independent input units. And I think this was just a unit question. Okay, that's activity 4. Activity 5 was calculating limits. Let's see. So activity 5 had the crystal growth problem. You don't have, you won't have anything like that on your exam. Sorry, your quiz. So looking down here, let's see. More like this. Okay, you're going to need to compute limits. So we've talked plenty about given an expression, if you're computing a limit, you take the 3 and you plug it in. If you have an indeterminate form like 0 over 0, you need to factor and cancel. That's what's happening here. Same thing for here. Let's see. Plug in the -2. Looks like we get 0 over 8. 0 over 8. So the limit is 0. That's it. You're done. Here's another indeterminate form. Factor cancel. We end up with 1. Here's another indeterminate form. We factored out an x in the numerator, and we ended up with 0 for our limit. Okay, that was activity 5. Activity 6. Okay, take the limit going to 16, and we got 0 over 0. It was a factor cancel problem or a conjugate problem. You should get 1/8. Anytime we had a root, typically we multiplied numerator and denominator by this 4 plus root x, the conjugate of 4 minus root x. This one, what happened? So we got 0 in the domain. Yeah, so if we plug in 0, that's no problem. We should get 4 over 5 minus 3. And then, yeah, that worked out. We got 2, so no big deal. Here, if we plug in 0, we get an indeterminate form. You should FOIL out, expand the numerator, cancel some things. You're left with a negative 32AH and a negative 16H squared. They factored out an H or even just a negative 16H. The H's cancel, and then you plug in the 0 just for the H, not the A. Here, indeterminate form, you have fractions again, so find a common denominator. That's what they're doing in this process. This was one of our daily problems. It was an indeterminate form of infinite minus infinite. So again, find a common denominator and simplify. Here, indeterminate form, we have a root, so find a simplified expression through using the conjugate of the numerator. That's the root 16 plus h plus 4 over the same thing. Then let's see. This problem was getting us to look at the different indeterminate forms. You will not be asked about that on the quiz. Let's scroll down. Were there others to compute? This, you should be able to look at a graph and determine limits. either limits, say as we approach 3 from the left, go into positive infinity, vertical asymptotes, the asymptote being the equation x equals 3, in this case, and x equals -2. So let's scroll down, more limits. This was one of our daily problems, 4 from the right. I believe we got a negative infinity. And so since we had a limit going to 4, and it was an infinite limit, that tells us x equals 4 is a vertical asymptote. Let's see what happened here. Oh yeah, so we've talked about this. The one-sided limit from the right was negative infinity. From the left, it turns out it was infinite. Since those one-sided limits don't match, our overall limit at 4 does not exist. If we take the limit going to 3, you plug in a 3, that's 6 over 0. That gives us an infinite limit. You need to decide, is it plus infinity or minus infinity? And we've looked at one like this, if not on our daily problem in our notes. The sign of the denominator going to 0 is always positive because of the square, makes it positive infinity. What happened here? We plugged in a 3, denominator goes to 0, numerator goes to 2. That's some sort of infinite limit or does not exist. Let's see. Yeah, our the best answer is it does not exist. If we look at the one-sided limits, we have one side going to positive infinity, the other negative infinity. Those don't agree, so the overall limit does not exist. What else? We plugged in 2 from the right. That looks like we had something canceling there. And when we look at just 2 from the right of what's left after canceling x minus 1, x minus 2, we get infinity. So again, taking the limit going to 2, an infinite limit, we get x equals 2 as a vertical asymptote. What happened here? We went to 3 from the left. It's getting 0 in the denominator. Did some things cancel? Sure. So we had 2x over x minus 3. If we're going to 3 from the left of 3, then the denominator is negative. Numerator is positive. So we should end up with a negative infinity. Again, taking a limit going to 3 from the left, we get an infinite limit. So x equals 3 is a vertical asymptote. And if we go look at our MyMathLabs, you're not going to have to fill in any tables with values like this, but calculating average velocities or average rates of change is something you should be ready to do with numbers that are friendly. So let's look at question 1. Again, that's formulas for average rate of change in outs over change in ins, and that would be the last one. Then let's see, second question. More slopes of secant lines also equal to average velocity. It would be not that one, it would be the top one. Change in outs over the change in ins in the same order. If you look at question 3, more average rate of change, be able to do that. Here, given a graph, draw the secant line whose slope represents average rate of change. It's the line through the 2 points. Then, we already said you don't have to do that. Same there. Okay, that was 2.1. 2.2, questions about limits. That could be a thing. This question, you're not going to have a question like this, but this is getting at, for a limit to exist, the one-sided limits have to agree. Then be able to look at a picture and identify limits. We did that today in class. Same thing here, look at a picture, identify limits. Question 5, look at a picture, identify limits. 6, look at a picture, identify limits. That's definitely a thing you're responsible for. And again, we did that today in class. Question 7, let's see, sketch a graph of f and use it to make a conjecture. You will not have to sketch any graphs. Let's see, you will need to take limits, but not sketch any graphs. Then let's see, you won't have to make a table like that. That's end of 2.2. 2.3, question 1, take a limit like this, you bet. Take a limit like that, yeah, limit of a constant is 1, or the constant. Here, take a limit, you plug in the -6, it is what it is, that's your limit. Question 4, plug in the -2, see what happens. Maybe it works out, maybe it's indeterminate. Same with -1. Looks like the denominator is going to be 0, but it looks like something's going to factor in the numerator and cancel out. So just like we've done before, you plug in the -1, factor cancel if it's indeterminate form. Same thing here, factor cancel indeterminate forms. Question 7, that is an indeterminate form, and you find a common denominator in the fractions. We've done that. Multiply by a conjugate, know how to do that. More conjugate things. Let's see, what would you do here? You'd FOIL out the numerator and try to cancel an h. And I think that's it for 2.3. 2425. Questions about asymptotes are a thing. You won't have to fill in tables like this. Question 3. Definitely, can you look at a graph? Determine limits. Can you determine asymptotes? Question 4. Find one-sided limits. Decide if you get an asymptote. Question 5, find, let's see, vertical asymptotes by finding a location where the function is undefined and then taking those one-sided limits. Describe the end behavior. That's taking a limit going to infinity. And based on what you get, do you get a horizontal asymptote? So again, to find a vertical asymptote, you take the limit going to a specific value, and if you get an infinite limit, you have a vertical asymptote at that specific value. For a horizontal asymptote, you take the limit going to either positive infinity or negative infinity. So in this case, the correct end behavior is that if you're plugging in, let's see, x value is getting really big positive, then this just goes to negative infinity, really big negative, it goes to positive infinity. The answer would be B here. But let's see, if you, just to be clear, if you took an infinite limit, like A here, and the limit had turned out to be 0, then that would tell you y is equal to 0 is a horizontal asymptote. Here, if you plug in infinity, this just gets really, let's see, x to the -21, that's like 1 over x to the 21. And if you plugged in infinity, the denominator would get really big. So this is like a fixed number over a big denominator, and it would go to 0, and y equals 0 would be your horizontal asymptote. We talked about these. So again, going to infinity, degree of the numerator is 2, degree of the denominator is 2, the limit will be 7. 7 over 1, the leading coefficients. You took a limit at infinity, it equaled 7, so y equals 7 is your horizontal asymptote. More of the same, take your limit going to infinity. We did not do any trig function limits. They're not going to show up on your quiz. The last thing, 2.6, dealt with continuity of a function. And what you should expect is to be able to look at a graph and decide where is it continuous or discontinuous, be able to write out an interval notation, or at minimum decide, okay, hey, this graph is discontinuous at -3, at 2 because there's a jump, at -1 because there's a hole, and then to be able to decide through the limit definition of continuity why the function is discontinuous at a point. So for example, at -3, the limit doesn't exist at -3, function's discontinuous at -3. Here, the limit exists, it's 3. The function value exists, it's 2, but they're not the same. So function is discontinuous at -2. At -1, the limit exists, but there's no function value, and then that's it. Let's see. Again, look at a picture, decide where it's continuous or not. We did this in class today. Question 4, let's see, determine intervals on which the function is continuous. You would only have to do that through a picture like we did in class today, not through a polynomial like this. Same thing there. Same thing here. You would not have to give a reason why it's discontinuous, whoops, at, say, -3, only through a graph. Same there. So these questions for determining continuity at a specific point, just with a function, you would not be asked to do that, only through a graph. similar to these questions. Could you look at a graph and decide if and where the function that you see is discontinuous and why according to the limit definition? Okay, I think that's plenty. Please reach out if you have questions, and reach out tomorrow if you have questions as well. Okay, y'all take care. See you soon.